Today's lesson is on section 2.4. Yesterday we talked about 2.5 or some things we're going to use soon in that section, but we're going to jump back to 2.4 today, multiplying real numbers. First thing I want you to copy in your notes is actually right off of page 89, this table of properties of multiplication. And again, just like the previous table we copied that was similar to it, just the highlighted section is fine. Last week we copied off some properties of addition. And as you look at these properties of multiplication, some of them may look familiar. Some of them even have similar names to them, like the first three: commutative property, the associative property, the identitive property. There's 5 properties here. I want you to have them in your notes. Again, are they the most important things we're going to learn all year? Not necessarily like we're going to talk about them every day, but if we jot them down, usually that's a better way for us to remember the problems, or remember these properties. And then when we do talk about them, we kind of have them in the back of our mind we can bring up again. So also if we see them on a quiz, and I'll let you use your notes and maybe some that you can reference and get a few answers right too. So in terms of the properties of multiplication, I'll just kind of talk about them here quickly. Number 1, again, looks like the property of addition. It says, or one we wrote down for that too, it says the commutative property. Again, remember, commute means like commuting, or a way to think about commuting means between one place to another. So like A to B, 2 points from A to B you're going. Commutative property means like 2 things. When you add 2 things together, or in this case multiply 2 things together, it does not matter what order they are in. So like 3 times 5 is the same as 5 times 3. They both give me the same answer. In multiplication that works, so that's called the commutative property. The associative property, similar, but just means that if I have 3 or more numbers and I multiply them all together, I'll still get the same answer. It does not matter how I group them or how I order that. Again, I think of associative property, think of like an association, or your associates. If you have a lot of people around you, you can think of those like the associative property. There's more than 3 or more numbers that you're multiplying together to get the same answer. So similar to the commutative, but 3 or more numbers we're talking about. We can group them anyway, order them any way we multiply them. We'll still get the same answer. The third one, the identity property. In addition, we had an identity property also. If we add 0 to any number, we still have that same number. Again, it keeps its same identity. For multiplication, this can happen too. If I multiply a number by 1, I still get the same number. So in this case, the 1 is kind of the number that keeps, for multiplication, will help a number keep its identity. So again, it keeps its same identity. It keeps the same number you get when you do the problem at the end. So I think that like the identity property, it keeps its own identity. So the last 2 are a little different than the additions, or different properties than we had in the addition properties. Number 4 here, property is 0. It just says when I multiply any number times 0, I get 0 for an answer. Again, maybe something you've kind of realized over time, maybe back in 1st grade when you're doing flashcards, but there is actually a property that says that, property is 0. When I multiply any number by 0, I just get 0 for an answer. And the last one, the property of -1, one we'll use once in a while when we're solving equations also. It says if I multiply any number by -1, I just get the opposite of that number. So 3 times -1 gives me -3. Or -10 times -1 gives me +10. Again, when we're solving equations, sometimes that will come in handy to get us the right sign for the answer. So that last one, property of -1. Also, again, you can copy these properties down on page 89 if you need to, but otherwise they're right here in the slideshow. Have these in your notes. In today's lesson, again, we're still in section 2.4. We worked on that on Monday. We're just going to add a little more algebra to the things we were doing on Monday. We're still going to be multiplying real numbers, and mainly, like we talked about, we're mainly going to concentrate on what happens when I multiply positive and negative numbers together. That's the main focus. We have to make sure we understand those relationships. On Monday, you may remember problems like this, like number 1 here, 3 times -4 times 2. When I'm multiplying these 3 numbers together, I can count up the number of negative signs, and that can tell me if the answer is positive or negative. There's 1 negative sign, so that tells me the answer is going to be negative for this particular problem. If there's an odd number of negatives, that's when I get a negative answer. If there's an even number, that's when they all pair up. Like 2 negatives pair up, and they all end up being a positive answer if I have an even number of negatives. So remember that rule from Monday. That'll still come into play today. In this problem, then I can just kind of worry about the numbers. 3 times -4 times 2 gives me 24, and I know it's going to be a negative answer, so -24. Well, now going to a problem like today, this 1a over here, I have a similar problem, but instead I have a little more algebra involved in this one. Now I have 3 times -4 times x. Again, that x, that's just a variable, stands for some number that I may be able to figure out later. Maybe they'll tell me what x is, but I just don't know what it is right now. So in that regard, I'm going to treat it like a number, though. It's going to still be in my answer, in my final expression, but I won't get some kind of final answer like a number, like 12 or like 18 or -2. I won't be able to get to that, but I will have an expression with x in, and then later if I find out what x is, I could plug that in and evaluate and find a final answer. So in this problem, though, again, we can still analyze it like problems we were doing on Monday. I see there's one negative sign, so I know my answer is going to be negative. And then I'll multiply the numbers together that I can, and then my variable will kind of come along for the ride here and still say I'm going to multiply that if I find out what that is. 3 times negative 4 would give me negative 12, and then that times x, I can just write that in algebra as right next to the 12 there, so negative 12x. So again, it makes sense. My answer was negative. I have a negative result there for the expression, but I still have x along with it because I don't know what that is yet. Moving on to number 2. Again, a similar problem like we had on Monday. I can multiply those three numbers together, but I know it's going to be a negative answer because I have one negative in the problem. 5 times negative 4 times 8. 5 times 4 gives me 20. Times 8 gives me 160, and I know the answer is going to be negative, so negative 160. Well, again, a similar problem today. I'm just going to have, instead of having three numbers, I might have a variable in there. But I can still do similar types of things. I can still multiply together the numbers together that I can, and then the variable will just kind of come along with in the answer. The associative property there on that previous page said that I can multiply these numbers in any order. So I can actually multiply the 5 and the 8 together. Since all these things are just multiplied together, it doesn't matter what order I do it in. I can multiply the 5 times the 8, and that gives me 40. And then the y I'm going to multiply by 40, or multiply that by 40 later when I find out what y is. But for now, it just has to stay in the final expression like that, 40y. Number 3. And actually, I'm going to cover up number 4 here. We'll come back to that problem soon. But just jump into number 3 right now. 3 says 2 times 3 times negative 4 times negative 5. Again, analyzing the problem, something I would hope you could do even without using your calculator. You could tell me if this answer is going to be positive or negative. There's 2 negatives in the problem, so again, it's an even number of them, so this should be a positive answer when I'm all done. 2 times 3 is 6, times 4 gives me 24, times 5 gives me 120. So there should be positive 120 for an answer. Well, again, a problem like today, maybe just a little more algebra involved in it, or at least a variable. I've taken out one of the numbers and just put h in its place. Again, I can multiply all the numbers in that problem together, though, and then just have the variable in my final answer as well, or my final expression. 2 times 3 is 6, times negative 5 gives me negative 30, and then again, I'm going to multiply that by h sometime in the future when I know what h is. Looking at problem number 4 here, and actually I'm going to start with problem 4a in this case, now that we've done a few of these problems together. This one says just something a little different. In this case, I have 3 times t again in this particular problem. So in this case, I have the variable, some number like almost that variable, whatever that number is, times itself. Maybe come back to this problem then for a second. Number 4, 3 times 5 times 5. Think about something like this where we have the numbers involved. What's another way that I can say, well, 3 times some number times itself? I want to say I want to multiply 5 times 5. There's a way we can write that in mathematics. If you remember, that way is when I put some number squared, like, or some number to the second power. If I want to say 5 times 5, I can just write it as 5 squared. That's another way I can write that's what I want to do, find that product. So now going back to the 4a problem, if I have 3 times t again, well, another way to write this part right here is just t squared. That means some number, whatever that variable is, t, times itself, t to the second power. And I'm going to times that by 3 at some point also, so 3t squared is the result for that problem. And we'll just take a look at a couple more examples here. 7, 8, 9, and 10 on this page. Number 7 says 10 times negative 7 times negative x, or sorry, negative k. I know this is something that sometimes can confuse people also when they see just a negative with a variable there in that problem. Remember, we've had problems like this just recently where I have something like 6x plus x. When there's no number right in front of the variable, it's the number, it's kind of implicit. It's a number we don't write in, but there is still a number there, a coefficient for that variable. It actually is a coefficient of 1. So like if I have 6x plus x, there really is 7x's here if I would add those two together. Well, same thing for this multiplying problem. I know I just see a negative here in front of the k, but really, if I want to rewrite this, I can rewrite this problem as 10 times negative 7 times negative 1k. Again, when you see a variable and there's no coefficient in front of it, or no number that you can see in front of the variable, there really is one there. It's really like a 1 is in front. So in this case, it'd be a negative 1. That can kind of help remind you then when I'm multiplying all this together, I'm going to multiply the three numbers together and see what I get for that answer. And then the k is going to kind of come along for the ride in that problem, and it'll be some expression with k in it. 10 times negative 7 times negative 1 gives me positive 70, and then I have k along with, so 70k is my expression for that one. Same thing on number 8 here. If I want to rewrite this, it may help to say 12 times negative 1t times negative 5, just to remind myself that there is a number in front of there, so number in front of that variable. 12 times negative 1 times negative 5 is going to give me positive 60, so positive 60t. Number 9. Again, in this problem, there's some numbers, some variables. Again, I'm going to rewrite it one more time to say, okay, well, I have this negative x here. I can think of it like negative 1x if I want, just to have a number there to help myself with the multiplication and kind of keep it clear for myself that I'm multiplying negative 1 when I see that negative. If I multiply just the numbers together, or again, I can even analyze the problem, again, going back to that. I can say there's 2 negatives in this problem, so I know my answer is going to be a positive answer. If I multiply the numbers together, like 12, negative 1, and 2, I'm going to get 24. And then here I have x times x times x again. So if some number times itself 3 different times, that's like writing x cubed, or x to the 3rd power. So this one ends up being 24x cubed. And then that last problem, negative 99 times b times negative 100 times b. Again, I can multiply the two numbers together, and negative times a negative gives me a positive. So that's going to be 9900 when I multiply the two numbers together. And then b times b gives me b squared. Some number times itself, that's how I can write that, b squared. So again, a little different from Monday. We're adding some variables in the problems. And some way some of these problems we're going to end up with like an expression for our final answer. But that's all right. That will happen sometimes. And maybe later we can solve an equation and find out what that variable is. Or maybe they'll tell us what the variable is and we can plug it in. So, but just another type of answer we can see when we're multiplying real numbers together.